All right, guys, 9.2. I know it's 9.2. Oh, yeah, that's the date, January. Okay, 1.6 in our old book, 1.9 in our new book. Doesn't matter the section number. This is inverses. Guys, what does it mean to be an inverse? What do we know about inverses?
Opposite.
They're opposites. Okay, here is a function. They give you the function. They give you the expression. They give you the points. Here's the inverse. All right, we're going to talk about these two things. First of all, function notation. Function notation is our f of x. That's a fancy way of saying what letter?
Y.
Y, okay. So notice what the inverse notation is. On your test and any sort of assessment thing, you guys need to note that something is an inverse. The way you do that is with this little -1 up in kind of where the exponent would be. It's not this. That does not mean the same thing as f -1. That notation right here means you are telling me that's an inverse. That is not correct. What do you guys notice about the function itself? The original and then the inverse. What do you notice?
They switched places.
The signs change, right? In the original, it was addition. Well, it's the inverse of addition, subtraction. If you look at the points, what happens with your x values and your y values from the original to the inverse? They switch, okay? That is the biggest thing that you guys can take away from this is that x and y switch places. You'll see why that means so much algebraically in just a second. Okay, again, this is a lot of math talk, and I know it doesn't mean much. So we're going to go through it, inverse notation. I want you guys to see that. When I look here, these two questions are going to kind of get us ready for going into inverses. We did a question yesterday on our notes. It was the last one that we did, and it said to plug F into G and then plug G into F and show that they were equal to each other. And I said to you, that's getting us ready to learn about inverses. This question right here is telling you that these are inverses of each other. You can kind of look at it and see that. In F, we're cubing, yes? And in G, we're taking the cube root. In the F function, we're subtracting 1, and in the G function, we're adding 1. In the F function, we're multiplying by 2, in the G function, we're dividing by 2. A lot of times, you can kind of do an informal assessment like that, but don't go to the bank and say, oh, it's all different, so it's fine. You have to actually graphically and algebraically show this. So in order to verify that two functions are inverses of each other, you're going to perform the composition of functions. You're going to do g of f of x, and then you're going to do f of g of x. I wrote it two different ways so you guys would see it. Whoops. Yeah. All right, you're going to take one, plug it into the other. Then you're going to take this one, plug it into the other one. So watch how we do this, all right? I'm going to take the f function first. I'm going to plug it into the g right where the x is. So I'm going to write my g function, and it's cube root. Everybody with me? Instead of the x, I'm going to write 2x cubed minus 1. And then I'm going to finish the g function. So it's plus 1 divided by 2. Questions. I took the f function, put it into the g. And now we're going to simplify. We start on the inside, we work inside out. What do I do with the -1s, guys? -1 and +1 do what?
They cancel.
They cancel.
Each other out.
So now I have the cube root of 2x cubed divided by 2. Well, now what can I do? What happens with the 2's?
Cancel.
They cancel. Good. And now I have the cube root of x cubed. And what happens when you cube a cube root? It cancels. So I'm left with just x. All right. Now to verify, yes. Now I'm going to do the exact same thing, but in reverse. So I'm going to erase this so I don't confuse anybody. And we're going to take the g function and plug it in to the f. So my f function is 2. Instead of x, I'm going to put in the entire function here. Everybody see that? Yes? And then I have...
I have a question.
Uh-huh.
Okay, so you know how how you canceled out the square root and the cube.
Mm-hmm.
Why, I'm just confused why you put the -1 inside the parentheses.
Don't get hung up on this. I'm just showing you. If they have a question, you're not going to have a question like this. But if you ever were to see a question that says which of these is the inverse, the way that you would solve it is you would take this function, plug it in here, and then vice versa. And you have to solve it to become x. Or you would take this function, plug it in here. So I'm going to do this quickly. Don't freak out. Just watch me. I'm going to take this first function. And I'm going to say, okay, instead of x, right, I'm taking f and I'm plugging it into g. Everybody with me on that? So I have 5 over x minus 2, right? Minus 2 over 5. If I went the other way, and I took this function and put it in here, I would have 5 over x minus 2 over 5 minus 2. In either case, here or here, can I do any simplification like we did before? Can I just easily cross out 5s and they undo each other and anything like that?
No.
No. Okay. So these are not inverses of each other. You can see that quickly. If you plug one into the other and it looks like a huge giant mess, like, oh my gosh, I have to do that, then they're not inverses of each other. It should, once you plug one into the other, it should naturally start to just cancel everything out. Okay? Again, don't get hung up on this. I'm not trying, you guys are not going to be tested on figuring out which is the inverse of what. You're going to be tested on find the inverse. So in this case, I'll show you real quick. And then if you have any questions about it, we'll come back to it. I just want to make sure we get to the meat of this. I'm going to take this function, h, I'm going to plug it in right there. So I have 5 over, this is 5 over x plus 2, and then the rest of my function is minus 2. Does everybody see that? Yes or no?
Yes.
Okay. So what happens to my 2's? They cancel out, so I'm left with 5 over x. Is this a fraction divided by a fraction? Yes or no?
Keep, change, flip.
Okay, so I'm going to keep, change, flip. So this becomes 5 times x over 5. What happens to my 5's?
Cancel.
Mm-hmm. So I'm left with just x, right?
Yeah.
Okay, so now we're going to do the same thing. Again, I'm just showing you. We're going to take this and plug it in right there. So I have 5 over. You guys still with me?
Yes.
Okay. 5 over x minus 2. And then plus 2. Did I write that right? 5 over x minus 2 plus 2. You guys with me?
Mm-hmm.
Okay. Graphically. When we have a function, they just call this a and b. This is our x and y, right? Graphically, if you have a function and it's graphed and you want to know the inverse, what happens to our x's and our y's? They do what? They switch places. So when you have a graph, this is my original function here, and when you switch the places of the x and the y, they become the y and the x, it's going to be reflected over this line, which is called y equals x. It's that horizontal positive line that slants upward. So if you have a function, they give you a graph and they say, is this the inverse? You're flipping it over this slanted line. That's how graphically you guys would do it. You're not using the x-axis or the y. The inverse is always going to flip over that horizontal, the diagonal positive sloping line of y equals x. This would be y equals x. All right, you're always going to just cut it in half diagonally, and it should mirror over. Like if we were looking at something that was symmetric to the y-axis, the y would cut it in half, right? If we're looking at something that was symmetric to the x would cut it in half. If you're looking for a graph to be an inverse of another graph, the line that's going to cut it in half is y equals x. It's this diagonal line that slopes positively. Again, you're not going to see that much. It's just the concept of how inverse graphs look. They are not symmetric to the x or to the y. It's to the diagonal line of y equals x. Does that make sense? Do you understand what I mean by that? Yes? No?
Yeah.
Okay. This is the meat of what we need to know with inverses. And you guys are going to use this a lot as we go along in pre-cal. So this is a very easy concept, I promise. You're not verifying, you're not telling if one is the other and trying to go back and algebraically is this going to work out. You guys are not going to have to do that because sometimes when we do that, it can be very simple or it can also be very convoluted and gets a little hairy. But in here, when you're finding the inverse, this is the easiest thing to do. They give you the function, you follow the steps, and then you can informally check at the end if it makes sense that this is the inverse of itself. So watch. I'm going to read these through, I'll talk to you about it a little bit, but then we're going to do some problems. You guys will be fine. It says, in the equation for f of x, replace f of x with y. I told you at the beginning, you guys all know that f of x is a fancy way of saying y. So the first thing you're going to do, cross out f of x, put y. Then you're going to switch the roles of x and y. You physically are going to take the x and the y and switch them in the problem. You're going to solve for the new y, and then you write your answer in function notation, f of -1 of x. So let's go through and do some problems together. Here's my function. The first step I told you to do. What's the first thing I told you to do? Cross off what?
The y.
Cross off the f of x and make it a what?
Make it y.
Okay. All right, now what happens when we talk about x and y? We talk about our domain and range. What happens to those values when we're talking about an inverse? We said it from the very beginning. The x and the y do what? They switch places. So that's literally what you're going to do now in order to solve algebraically. I'm going to switch the places of x and y. So I have x equals 5 minus 3y divided by 2. And now that we have our new equation set up, we're going to solve for y. If you skip that step of not switching x and y, you will never get the inverse correct. Inverses are opposites. They switch. X and y switch spots. So it is super important that you do that first step. Once you do that, let's solve. How would I get now y by itself? What's the first thing I would do? Good. Multiply both sides by 2. So I have 2x equals 5 minus 3y. Then what?
Subtract 5.
Subtract 5 from both sides. So I have 2x minus 5 equals -3y. Now what?
5.
Good. Divided by -3. So I end up with y equals 2x minus 5 divided by -3. If this is a 10-point question, and that is the answer that you give me, you're going to get like 6 or 7 points. What's my issue? Why is this not going to be full credit?
Because there's a negative on the denominator.
No, you can have negative. It's okay.
It's not in function notation.
It's not in function notation. This is not telling me, hey, this is the inverse. How would you note to me that this is the inverse of the original equation that you got?
Do the f to the -1.
Yes, ma'am. F -1 of x equals 2x minus 5 divided by -3. Now, I told you guys at this point, you can do some, like a lot of you like to check, which is fantastic. You can do kind of an informal check here. Compare your original to your inverse. Okay, let's talk about it for a second. Look at each piece separately. Right here, I have a positive 5. What do I have down here?
-5.
-5, okay? And then I come over here and I say, oh, I'm multiplying here by -3. What am I doing down here? Dividing. Here I'm dividing by 2. What am I doing here? Multiplying by 2. You should be able to take your original and take your answer, and each little piece of the equation, you should be able to see that it's an inverse from the original to the answer. You guys see what I'm saying?
Yeah.
Okay, does that make sense? So if we go on to number 2, let's do number 2 together. First step I need to do. This is how you guys would show me your work. Yes, what's up?
For number 1 again.
Mm-hmm.
If you're
And that we're looking at, not necessarily the sign.
okay.
I see what you're saying because here it was a positive 5 and then a negative 5, but in reality, it's you're adding 5 and subtracting 5. Dividing 3, multiplying by 3, 2, and 2. You're looking at the operation itself, not necessarily the sign of the number that's with it. That's why I said it's informal. It's not going to be exact, but the operations will be inverse of each other. So if I look at this one, f of x, I change that and make it a what?
Y.
Okay, thank you. So y equals 3x plus 4, divide by 5. I have absolutely no idea why I'm writing so big. What's my next step? That if I don't do, I'm going to get the whole problem wrong.
You
Switch to
We
Y.
got to switch. We have to switch. So I have x equals 3y plus 4 divided by 5. So I'm here. I'm solving for y. So what am I going to do? How do I get y all by itself?
multiply by 5.
Perfect. Multiply both sides by 5, because what you do to one side of the equation, you do to the other. So 5x equals 3y plus 4. Now what?
Subtract by 4.
Perfect. Subtract 4. 5x minus 4 equals 3y. Now what?
Divide y.
Divide by 3. So I have y equals 5x minus 4 divided by 3. And I need one more thing. I cannot leave my answer like that.
Function notation.
Yep, function notation. F negative 1 of x equals 5x minus 4 divided by 3.
And we keep the x in the answer. We don't like switch anything.
Nope, no. It's where it's supposed to be now. So now if I look, just an informal look. In the original, I multiplied by 3. In the inverse, I did what? Divide by 3. In the original, I added 4. In the inverse, I did what?
Subtract.
Thank you. In the original, I divided by 5. In the inverse, I did what?
Multiply by 5.
Thank you. Thank you. It's just an informal check, kind of like, hey, did I check off all the boxes? Does it look like I did everything I needed to? Let's look at this last one. Oh. First thing I need to do is,
Square. Oh, change it to y.
okay, good. I do like the thought process, though. There's Zoe, good. So now I'm going to switch what? I have to switch.
The x and the
I got to
y.
switch the places of the x and y. You guys, that's super important. That's the whole concept of inverses. So I have 2y minus 3. Now I'm going to solve for y. I need to get y all by itself. I cannot do anything. I can't divide by 2. I can't add 3. I cannot do anything because there is a square root over my entire expression. So what do I need to do first?
Square both sides.
I need to square both sides. Good. Square this side. Square this side. So I have x squared equals. When you square a square root, they cancel out. So now I have 2y minus 3. Now what?
Add 3.
Add 3. X squared plus 3 equals 2y. And then divide by 2. Good. So you have y equals x squared plus 3 divided by 2. Guys, every time I have a variable on the right-hand side, I always move it to the left-hand side just because I like the way it looks. If you left it as x squared plus 3 divided by 2 equals y, that's perfectly fine. This just drives me insane that a variable's on the right-hand side. It's just because I'm a weirdo. So, but every time, I don't know if anybody noticed, I always do that. You don't have to. I just don't like it over there. One last thing. I cannot leave it like this.
Function notation.
Function notation. If you put f negative 1 of x, I would not mark it wrong. But what is the proper way to write this function notation?
G negative
G.
1 of x.
Yeah. If you could stay on par with what you're doing, what letters you started with, I'd appreciate it. But it's really and truly, it's not that big of a deal, I promise. All right. Is that incredibly difficult?
No.
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 This is going to draw